For more than 50 years, humanity looked at the moon and assumed the story was over. We had landed there. We had planted flags, collected rocks, taken photographs, and returned home. So why are the world's most powerful nations now racing back? Because the moon may be hiding far more than anyone imagined. A record of the solar system's violent birth, enormous reserves of frozen water, and perhaps the first real gateway to life beyond Earth. The Apollo missions changed history, but they explored only a tiny part of the lunar surface. Every crew landed on the near side, close to the equator, where communication was easier and the terrain was safer. The far side remained untouched. The poles remained unexplored, and the deepest craters were left alone. On Earth, the past is constantly erased. Rain breaks down rock. Wind reshapes landscapes. Oceans hide ancient impact sites. Volcanoes bury old terrain, while tectonic plates recycle the crust. But the moon has no weather, no oceans, and almost no geological activity. A footprint can survive there for millions of years. A crater created billions of years ago can still look almost fresh. That is why the moon is often described as a giant museum. Nearly 4.5 billion years of history remain preserved in its stone, dust, mountains, and impact basins. Some craters formed when asteroids and comets repeatedly struck the young Earth and moon. Those objects may have delivered water and organic compounds to our planet, perhaps even helping create the conditions for life. Earth erased most of that evidence. The moon did not. Even lunar mountains tell a remarkable story. Many mountains on Earth take millions of years to form. On the moon, some were created in seconds. A massive impact compressed and melted the crust. Then the surface rebounded upward and froze into a central peak. The largest collisions created entire rings of mountains. Some enormous basins may expose material from deep inside the moon, helping scientists understand how rocky planets formed. But another discovery transformed the moon from a scientific archive into a possible human outpost. Water. For decades, the moon was considered completely dry. Then, in 2008, India's Chandrayaan-3 detected signs of water-related molecules near the poles. 1 year later, NASA deliberately sent a rocket stage into a permanently shadowed crater. The CROSS probe flew through the debris and confirmed that water was there. Because the moon's axis is only slightly tilted, sunlight never reaches the floors of some polar craters. These places remain in permanent darkness, with temperatures lower than those on Pluto. Inside these natural freezers, water ice may have survived for billions of years. Before we continue, support the video with a like. Tell us in the comments whether humanity should build a permanent base on the moon, and write where in the world you are watching us from today. Because this ice is not valuable only to science. Astronauts could use it for drinking. It could help produce breathable oxygen, and by separating water into hydrogen and oxygen, future explorers could create rocket fuel directly on the lunar surface. Instead of carrying every kilogram from Earth, spacecraft could eventually refuel on the moon. And because lunar gravity is only 1/6 of Earth's, launching from there requires far less energy. The moon could become humanity's first fuel station in deep space. That is why the southern polar region has become the main target of modern missions. On August 23, 2023, India's Chandrayaan-3 successfully landed there. Its Vikram lander made India the fourth nation to achieve a soft lunar landing, and the first to reach the southern polar region. The Progyan rover rolled onto the surface and analyzed the soil. It detected sulfur, oxygen, aluminum, and other elements. It did not find exposed ice, but it proved that India could operate close to one of the most important regions on the moon. Months later, Japan's Slim lander attempted something different. Its mission was not simply to reach the surface, but to land within about 100 meters of a chosen target. In January 2024, SLIM came down near Shioli crater, missing its target by only about 55 meters. The landing was rough. One engine failed, and the spacecraft ended up tilted, with its solar panels facing the wrong direction. For several days, the mission appeared finished. Then the angle of sunlight changed. The panels began producing power, and Slim woke up. To tiny rovers photographed it, including a transforming spherical robot. Even more surprisingly, SLIM survived lunar nights. It had never been designed to endure. India demonstrated access to the South Pole. Japan demonstrated extreme landing precision, and together, they proved that the new race to the moon would involve far more than only the United States and China. While India and Japan proved that new nations could land on the moon, South Korea entered the race from orbit. Its January spacecraft carried ShadowCam, an instrument designed to see inside craters that receive almost no direct sunlight. These dark regions may contain deposits of lunar ice. China, however, moved even further. In 2019, Chang'e became the first spacecraft in history to land on the far side of the moon. Because that region cannot communicate directly with Earth, China first placed a relay satellite beyond the moon. The U-2 rover examined rocks, measured radiation, and used radar to study beneath the surface. Then, in 2020, Chang'e collected lunar soil and delivered it safely back to Earth. The samples were younger than most Apollo rocks and contained traces of water linked to the solar wind. The mission also demonstrated several steps needed to land astronauts on the moon and bring them home. China has discussed sending astronauts there before 2030 and building a long-term research station with international partners. Once again, the main target is the South Pole. That is where useful sunlight may exist close to suspected deposits of ice. But the best landing areas are limited. If several nations choose the same craters, bridges, and resource zones, who decides how close they can operate? The Outer Space Treaty requires peaceful activity, but it does not answer every question about mining, safety zones, or ownership of extracted resources. The United States is following a different strategy. Instead of relying entirely on NASA-built spacecraft, it is paying private companies to deliver instruments and cargo. In February 2024, Intuitive Machines landed Odysseus near the South Pole. It was the first American soft landing since Apollo 17. Navigation problems caused a hard touchdown. One leg was damaged, and the spacecraft ended up tilted. But Odysseus continued transmitting data. The mission proved that a commercial company could reach the moon and deliver NASA equipment. NASA's larger plan is called Artemis. Its purpose is not to repeat Apollo, plant another flag, and leave. The goal is to support repeated missions, larger crews, cargo deliveries, scientific stations, and eventually a long-term human presence. The first major test came in November 2022. Artemis 1 launched the Space Launch System rocket and the Orion spacecraft without a crew. Orion flew around the moon, traveled farther from Earth than any previous spacecraft designed for astronauts, and returned safely after more than 25 days. The next step is Artemis 2, which is intended to carry 4 astronauts around the moon without landing. After that comes Artemis 3, the mission designed to return humans to the surface. 2 astronauts would descend near the South Pole, while the others remained in lunar orbit. But Artemis depends on far more than Orion. NASA selected a modified SpaceX Starship as the first landing vehicle. Blue Origin is developing another lander for later missions. New spacesuits, cargo vehicles, power systems, and the planned Gateway station must also be ready. Apollo was designed to win a race. Artemis is supposed to build an entire transport system between Earth, lunar orbit, and the surface. Behind all of this stands a growing rivalry. The United States wants to reach the South Pole before China establishes a major presence there. China wants to prove that its program can equal, and perhaps surpass, the West. Both sides are looking at many of the same locations. Both understand the value of lunar ice. And both know that reliable lunar Transport could influence the rules of exploration for decades, but competition does not have to turn the moon into another battlefield. Scientists still exchange research, and discoveries made by one mission often guide the next, because the true value of the moon is larger than any single flag. Its frozen craters may reveal how water reached the inner solar system. Its ancient rocks may preserve chapters of Earth's history that our own planet destroyed. Its surface may teach us how to build shelters, produce fuel, grow food, and survive far from home. And if humanity ever reaches Mars, the road will almost certainly begin here. So the new race to the moon is not really about repeating the past. It is about deciding what happens next. Will the moon become a laboratory shared by many nations? Will it become a commercial frontier controlled by whoever arrives first? Or will rivalry divide its surface before permanent settlements even exist? No one can answer those questions yet. But one thing is already clear. The moon is no longer only a monument to the achievements of the 20th century. It is becoming the testing ground for the 21st. And the next footprints placed in its dust may not mark the end of another mission. They may mark the beginning of humanity's life beyond Earth.